Chapter 3, AP Computer Science. The goals for this chapter are to talk about superclasses and subclasses, the inheritance hierarchy, polymorphism, type compatibility, abstract classes, and interfaces. Inheritance is a way that we facilitate code reuse. Remember that the most expensive part of any software development project is the people. So anytime we can reuse code, we're going to save money on our people, on our programmers. One of the great ways to do this is with inheritance. For example, we can set up a superclass that's at the top of the inheritance hierarchy, the superclass that defines some general things about any of our objects. So for example, let's say we work for Toyota and we want to design the Toyota vehicle class. And it's going to have the cute little Toyota logo on the front, and it's going to have 4 tires, and it's going to have a steering wheel and an ignition switch and a brake and a gear shift and a front seat. Then we can define subclasses that add to everything that a Toyota is, but then they make it specific. For example, if you wanted the Cho subclass, you might add a clever little saying across the back of the car. You might add crank windows that make it a Cho. You might add a super reliable engine and a lot of personality. I'm not sure how you exactly add a lot of personality, but that definitely makes a Cho a Cho. If you want to add a Highlander, I'm not even sure what that is, but I think it's big. The Highlander subclass might use more fuel. It might have large captain's chairs and leather seating and so on. So these are specialties or specifics about each subclass that adds to your superclass. So the superclass is more general and the subclass has everything that the superclass has, but it's more specific. Inheritance defines the relationship between two objects that share characteristics, such as a Highlander sharing everything that a Toyota vehicle has. A new class, a subclass, is created from an existing class called a superclass. We already talked about that. And everything in the superclass is absorbed into the subclass, plus some added new features. Now, when I say everything, I don't really mean everything. I mean almost everything, and we'll see the exceptions here in a little bit. But basically, any state, that's your instance fields, and any behavior, those are your properties, are going to be inherited by the subclass. And again, the subclass is bigger than the superclass because it contains more data and methods. But the superclass might contain more objects because there are more Toyota vehicles than there are Highlanders, for example. The inheritance hierarchy, a subclass can be a superclass from another subclass. So you might have the Toyota superclass, and from there you might have the compact subclass, and from there you might have the Cho subclass, the Echo subclass, and the Yaris. These are shown in an UML diagram. UML stands for Unified Modeling Language. And if you just hit the pause button and turn to page 132 in the book, you'll see a diagram of an UML diagram showing some a hierarchy of classes. There is an open up arrow, and this designates is a. That means that a Toyota Echo is a Toyota. It's always drawn this way. If you put the arrow the other way, it doesn't make any sense because a Toyota vehicle is a Echo. Doesn't make sense because a Highlander's not an Echo. I mean, it's not nearly so cool. Looking at the example on page 132, employee is a person. Student is a person. Is a student an employee? Not necessarily. Is a person a student? I like to say we're all students of life, but I don't think that that is an accurate representation of what most people would say for students. You might know people who are not students. Let's see. Sorry, I lost my place. You can have two methods with the same name in the superclass and one in the subclass, and the subclass is said to override the method in the superclass. It masks it. So when an object of the subclass calls that method, it will call the one in the subclass, not the superclass. If you maintain part of the original, it's said to partially override the method in the superclass. For example, if you take a look on page 132, and I'm sorry, 133, and you see public class student, you'll see the instance fields for student. There's a static with the number of tests that they've taken, name, tests, grade. You see your constructors and your get and set methods and compute grade. But flipping over to the next page, page 134, take a look at the compute grade method. The compute grade method on page 134 is exactly like the compute grade method on page 133 in that it's public void compute grade with no parameter list. However, they do different things. The compute grade in the superclass says if there's no name, there's no grade. If they have greater than 65, they pass. Otherwise, they fail. In the undergrad, it doesn't ask about the name. It just says if their grade is over 70, then they pass. So you see that the method in the undergrad class overrides the method in the superclass. Now take a look further down on page 132, the grad student class. You'll see that compute grade, public void compute grade, has the same method header as in the student class, but look, the first line of code is super.computeGrade. So we're explicitly calling the compute grade method in the superclass. It's going to do all of those things and then return control here, where it determines if they pass with distinction or not. And that's overriding. I would like you to hit the pause button here and go ahead and create the program on page 133 and 134. Note that each of these files, undergrad, grad student, student, they all need to be in their own Java file, their own Java class. So you can't just type them all up. You have to continue to go up to File, New File to add them to your project. Because remember, a Java class needs to be in a file with the same name. So your student class will be in a file called student.java, your undergrad class will be in a file called undergrad.java, and so on. Inheriting instance methods and variables. All methods and variables of the superclass are inherited by the subclass except constructors. Note that code you just typed up from page 133 and 134. You had to rewrite the constructors all over again. On page 134, public class undergrad extends student. That keyword extends, by the way, you probably could have determined that by now, but it sets up the inheritance relationship. It says that undergrad is going to have everything that student has. But look, it's got public undergrad, so it's got its own default constructor, and all it does in the default constructor is it calls super with parentheses. What that does is calls the default constructor in the superclass. So super with parentheses will call the constructor. Look down a little bit further on page 134, public undergrad string student name, stud name, int, and that the square brackets mean it's an array, and we'll get to that in chapter 6, I think. String student grades and student grade, excuse me, and then super, and you're passing those three parameters now as arguments to the three argument constructor in the superclass. If you're going to call the superclass constructor, the very first line in your constructor must be to place that call to super. If you do other things in your constructor, these don't, but if you did, those would have to follow. For example, down on page 134, grad student, the default constructor for grad student, it places the call to super first, and then it sets grad ID to 0. So constructors are not inherited by this subclass, and neither are private members of the superclass. They're inherited, but you can't access them. So they're there, but you've got to use the public interface of the superclass to be able to get at those private members. We already talked about method overriding, but just to show one more time, we use the super keyword when we want to do a partial override. For example, compute grade on page 134. We call super first. We call compute grade, super.compute grade, and then we add to it afterwards. So the first thing is our call to super.computeGrade, and then we add the extras that we want to. That's partial overriding. So we call that method in the superclass and then do something different as well. If we didn't want to override it at all, if we didn't have a compute grade method in our subclass, it would look in the subclass, and if you place a call to compute grade, it would go to the subclass and say, where is it, where is it, where is it? Can't find it. I'm going to go look in the superclass, and then it will find that method in the superclass. Constructors are never inherited. If there's no constructor written for a subclass, the superclass default constructor will be run. If the superclass does not have a default constructor, you'll get a compiler. It will not compile, it won't run. To call the constructor in the superclass, always use the keyword super. If super is used in the implementation of the subclass constructor, it must be the first line of the constructor body. We already talked about that. If no constructor is provided in a subclass, the compiler provides the following default constructor. So we wouldn't see that. You could just know that that's in the background. It's kind of like an implicit parameter. You don't actually see that default constructor, but that's in effect what's happening.